These are the practice problems for week 6, which is focused on regression. Again, there are two practice problems, one that we're going to look at together on candy and cavities, and the other one, which has to do with games and attendance in a youth group, will be the one that you'll do on your own following the example that we're going to do together right now. So suppose I collect a random sample of 100 kids between the ages of 6 and 10. We want to know if there's a relationship between eating candy and getting cavities. So on average, I find that kids eat 4 pieces of candy each, with a standard deviation of 1, and have a mean of 5 cavities, with a standard deviation of 1.5. The correlation between these variables is 0.40. Okay, so what is my independent variable, my x term? Well, the independent variable is predicting the dependent variable, and so in this case, eating candy is predicting cavities. So my independent variable is candy, or amount of candy eaten. Right? The x bar, that's the mean, right? The mean of my sample. So the mean, see, it says on average they eat 4 pieces of candy. So my mean is 4. And then my standard deviation, so S subscript x, S sub x, that's the standard deviation of the x distribution. So in this case, that is 1. So mean of 4, standard deviation of 1. The dependent variable, my y variable, is cavities. Oops, cavities. There we go. The mean of y, right? So y bar is, let's see here, 5. And the standard deviation, S sub y, is 1.5. Okay, so it can be useful to kind of get this straightened out, make sure we're clear on what's x and what's y. Now, based on the data I collected in my study, how many cavities would you expect a kid to have who eats 7 pieces of candy every day? So apparently this is how many pieces of candy they eat each day. Yeah, candy each day. And then at some point how many cavities they're going to have. So first, let's see. So here's our regression equation. So we have y hat. So this is the predicted or estimated y being candy. So the estimated or predicted number of cavities equals a. That is our slope intercept, plus bx. So x is the independent variable, in this case, which is candy. And then b is the beta coefficient. So we would multiply that times the number of pieces of candy, add that to our slope intercept, and that would give us our predicted value. So first thing we have to do is calculate the regression coefficient, or b. And the formula for b is r, which is the correlation, which we already know is 0.40, times the standard deviation of the y variable, which is cavities, over the standard deviation of the x variable, which is candy. So basically, r is a standardized unit of the relationship, and we're essentially unstandardizing it and putting it back in the original units. That's basically what we're doing. So we know that r is 0.40, so we'll put that right there. The standard deviation of y is 1.5. I color coded that for you. The standard deviation of x is 1. Okay, so b is 0.40 times 1.5 divided by 1. Well, anything divided by 1 will be itself, so 1.5. And now we need 0.40 times 1.5. So we'll go over to our handy dandy calculator. 0.40 times, the stars times 1.5, which will give us 0.60. So our beta coefficient is 0.60. Very good. Well, moving on down here, we're going to calculate the slope intercept, which is a. Remember, the slope intercept is the expected value of y when x is 0. Right? It makes sense because if x is 0, anything times 0 is 0. So this whole term would cancel out, leaving just the slope intercept. So this would be the number of cavities you would expect to have if the child ate no candy, 0 pieces of candy a day. Right, so that's the significance of that intercept. So the slope intercept is the mean of y minus the beta coefficient, or the regression coefficient, times the mean of x. So the mean of y we know is right up here is 5. That's the average number of cavities. Our beta coefficient we just calculated at 0.60. And then the mean of x is 4, the average number of pieces of candy. Okay, So 5 stays 5. We multiply 0.60 times 4. So we already have 0.60 times 4, which gives us 2.4. 2.4. And then we subtract 5 minus 2.4. So we'll do 5 minus 2.4, which will give us 2.6. There we go, 2.6. So basically this means that if the child eats no candy, 0 pieces of candy a day, we would expect the child to have 2.6 cavities, so an average of 2.5 cavities. Now, we're going to construct the final regression equation below. So we know that A is 2.6 because we just calculated that. And we know that B is 0.60 because we calculated that too. So the way this equation works is to find out how many cavities. We're going to start with the 2.6 that we'd expect if they ate no candy. And then for every piece of candy they eat a day, we're going to increase the prediction by 0.6 cavities. So use the regression equation to calculate the predicted number of cavities for a child who eats 7 pieces of candy every day. 7 pieces of candy. All right, so we're just recreating the equation here. So 2.6 plus 0.60. So all I did was just recreate this equation. Exactly the same right here. Right? So this stays the same, 2.6. The coefficient stays the same, 0.60. And now I'm substituting, for x, I'm substituting 7. Right? So 7 pieces of candy a day. So that's what the x is, because x is the candy. And then now this stays the same, so that's 2.6. And then 0.60 times 7. I'll clear that. So 0.60 times 7, right, equals 4.2. There we go. And now we'll simply add 2.6 plus 4.2, which will give us 6.8. So if a kid eats 7 pieces of candy a day, that kid is expected to have 6.8 cavities. Okay, well that's how that works. That's how you calculate these coefficients and the slope-intercept, and how you would use the equation. I will mention though that you can also solve for x. So if we wanted to turn this around and say how much candy would a kid have to eat to have 10 cavities, you could put the 10 in here, and then solve for x. Right, so you'd subtract this term and then divide, and that would give you your x. So it works either way. You can always solve for x or y. Okay, hope you find that helpful.